Hello, ladies and gentlemen. Today we're going to take a look at a concept called arc length. So for this, you're going to need your formula sheet, a calculator, as well as your notes. So you can be writing some of those examples in there, okay? I'm looking for examples, not just copying down those formulas. So arc length, here's what we need to know because there's some new words that are happening here. Remember last week when we talked about, or in the days prior to this, when we talked about circumference and area of a circle? So remember those formulas, circumference equals 2 pi r, and area is pi r squared. Remember that circumference when we talk about a circle is the distance around the circle, kind of like the perimeter here. Whereas area would be how much space is inside the whole circle. Those are two different concepts. And we're going to work specifically with one of those concepts more today, and that's circumference of that circle, okay? Because we're going to be talking about what is an arc. Get this part in your notes. An arc is just a piece of a circle. So what does that look like? It looks like this picture over here. I would copy this picture in my notes as well. An arc is a piece of a circle. This red part right here is an arc. It's a piece of that ring of that circle right there. Now that arc can be measured two ways. It can be measured in terms of degrees. How many degrees out of the full circle is that arc? Now if we remember, a full circle is 360 degrees. So sometimes that arc is 100 degrees out of the full circle. Sometimes it's 60 degrees out of the full circle. But when it's measured in degrees, it will have this notation. Measure of arc AB. The measure means that I'm trying to find the degrees. Okay, I'm trying to find that degrees. However, arcs can also be measured in terms of their length, so inches, feet, centimeters. The way that's noted, or the way you know to do that, is when somebody specifically says you need to find the arc length of A to B. Okay, so not degrees, but specifically how long it would be if you took a tape measure and stretched it around that circle to find that length. So there are two ways to measure arcs, in degrees as well as their units of inches and feet. That's called arc length. So on your formula sheet, this is the formula we need to write down. Here it is. To find arc length, or to help us calculate other things when given an arc length, here's our formula. We're going to do the measure of arc AB in degrees divided by 360 degrees, because that's a full circle, is the same or equivalent equals arc length over circumference. Now remember, circumference is 2 pi r. And you can jot that down underneath that word circumference if you want to on your formula sheet. That would be great. So this is our setup every time we're trying to find arc length. Now we have three examples here. Let's get these into your notes. Here's the first one. Example 1, you need to draw the picture and write down those words there. It says find the arc length of G to H. So in my diagram here, I see I have a circle. It has a radius of 11. I also am seeing a 120-degree portion that's kind of been sectioned off here. We want to know the arc length, how long it is from G to H. And to do this, we're going to use our formula setup. We have two ratios making a proportion here, and on the top of the first one is the measure of the arc in degrees. Because there's a 120-degree portion kind of sectioned off there, we're talking about 120 degrees out of 360. Equals, and on the top of the second fraction is where arc length goes. Well, that's what we're trying to find, so we'll put an X there. And on the bottom is the circumference. The 2, the pi, the radius. So we need to find 2 times pi times radius here. So 2 pi 11, because that's our radius, 69.11. And now to solve this, remember when you have fraction equals fraction here, we're going to cross multiply to solve our proportion. So 360 times x is 360x. Our 169.11 times 120 is 8,293.8. And then we go ahead and divide that by 360 to solve. X equals 23.04. Labels, we found the length from G to H, so we're talking about centimeters here. So that means if you stretch the tape measure from G to A, all the way around, curved it around there, it would be 23.04 centimeters. Here's a second example. How can we use that arc length to find other things about our circle? So sometimes you're not just trying to find arc length. Here's a second example. We're going to try to find the circumference, C, of circle Z. And that means the Z is the center of the circle. Now notice what we have here. We have the degrees that are given, and we also have a piece of the circle that's kind of been sectioned off, and it says that that's 4.19. So we're going to use the same formula to set this up. How many degrees are we talking about? We're talking about a 40-degree piece out of 360 equals, then the top of the second fraction is arc length. That's what this number represents. 4.19 is the arc length from X to Y that's given to us. We're trying to find circumference, so that's where we're going to place the X. And once again, we're going to cross multiply. 40 times X is 40X. 360 times 4.19 is 1,508.4, and we'll go ahead and divide now by 40 to get the X alone, 37.71, and that would be inches because that's the whole circumference. Okay, so 37.71 would be the distance all the way around the circle. And now our last example, ladies and gentlemen. We now need to find the measure from R to S, the arc RS. Measure, remember, means I'm looking for the degrees. Okay, what are the degrees from R to S here? So here we go. Set up our fraction. We don't know the degrees out of 360 equals the second fraction, the top has to be an arc length. Looks like the arc length here is 44. So we're going to place that 44. And then on the bottom is our 2 pi r, our circumference. 2 times pi times radius. 2 pi 15.28. In a calculator, roughly 96. So now when I cross multiply, 96x, 360 times 44, and then divide by that 96, x equals 165. 165 what? Think about what we were trying to find. We were trying to find the measure in degrees, so 165 degree portion of that circle is that arc length, okay? So that's what we're looking for. We're going to use this formula many, many times to find many, many different things. Thank you for taking good notes, ladies and gentlemen.